Hi, my name is Doug Curl from the Kentucky Geological Survey, presenting this poster about the development and evolution of the map service we've used to deliver geologic maps and other geologic data to the public for the past 15 years. The story of this map service really starts in about 1960 with a joint geologic mapping program between KGS and the USGS to produce detailed 1 to 24,000 geologic maps. This was completed in 1978, and those mappers produced 707 individual geologic maps, which covered the entire state of Kentucky, and we really became the first large state to be mapped at this detail. In 1996, we picked up those maps again and started a program, mostly funded with USGS funds, to convert those 707 maps into GIS datasets. We scanned the maps, registered and rectified them, and then the features were digitized using ArcInfo and AMLs that KGS developed. We digitized polygons of the geologic units, geologic contacts, faults, and many of the other features that were on the original maps in order to capture the entire map into a GIS dataset. At the same time, we also made the decision to scan the stratigraphic descriptions from each stratigraphic column on the sides of the map. And we used OCR to import those descriptions into the KGS SQL relational database. Then we used the database and the attributes of the GIS features to preserve the stratigraphic position of the descriptions. By doing this, we could connect the descriptions to the map and provide rich geologic information about those mapped geologic units in a GIS. And we also symbolize and arrange the map units by their stratigraphic position. Later on, this turned out to be a really good decision when we developed the Internet Map Service and could use those descriptions in the database to enhance the information returned to the map users about the geologic units. So these data sets that we produced were called digitally vectorized geologic quadrangles, or DVGQs for short, and we completed digitizing all 707 quads in 2006. Then we took those individual DVGQs and compiled them into a statewide seamless GIS dataset. That statewide dataset is similar to the smaller DVGQs. It is comprised of detailed geologic polygons for geologic units, faults, contacts, structural contours, and then other features like coal beds, structural points, and other geologic beds. So in 2004, even before we completed statewide digitizing, we started developing a web application for disseminating this data to the public. At this time, web maps were just taking off, and we got into the game by using Esri's ArcGIS ActiveX connector, which allowed us to create a customized map service using HTML, JavaScript, and ASP with no plugins required. That part was important because we really didn't want people to have to use Flash or Java applets or that sort of thing. And the map service was, of course, cost-free to users. So we also decided to put our other geological data sets, such as oil and gas wells, water wells, hazards data, coal data, into the map service so that users could overlay them on the geologic map base. In 2010, when Esri got rid of ArcIMS, we migrated the map service to ArcGIS Server and rebuilt the application using the Esri ArcGIS JavaScript API. This was a major enhancement because it gave the user a much faster slippy map experience similar to Google Maps, where at least the base map is loaded on the fly with panning and zooming, versus the slow loading and unstable ArcIMS experience. And again, still no plugins were required. In 2013, we took the JavaScript API and developed a separate mobile version of the map application because the initial version could not be easily used on a mobile device. Had much of the same layers as the desktop version, but has a much simpler functionality. So if we look at our website use of the map service since 2004, we've averaged about 62,000 hits of the application per year. But we know that our largest user bases are oil and gas users. And so here I plotted the trend of oil and gas prices with map service hits. And you can see the trend of the map service kind of follows oil and gas prices. And that makes sense because the oil and gas users use this map service quite a lot for viewing the locations and exploring oil and gas wells and related data. But we do have a steady use of the service from other types of users, including from industries such as consulting and mining, education, and the general public. And we know this from our web stats and from the feedback that we get. I also plotted mobile usage on here. It's a bit washed out by the regular version line, but its usage has increased about 30% since we released this application in 2013. So this year we released a complete redesign of the application. We're using the newest version of the Esri JavaScript API and taking advantage of cache layers that are much faster to display, pan, and zoom. And we can show the detailed geology at all scales, which is really nice. We also streamlined the user interface, added some new tools such as a custom bookmark tool, and importantly, this is a responsive design that works on mobile devices and tablets, and so we don't need to maintain two different versions. So I encourage you to check out the map service. You can use the URL or the QR code to access it, and you can access it from the KGS website. So thank you, and let me know if you have any questions or comments.